Hi, my name is Shao-Chieh. Today I'm going to talk about our scholarly project at Purdue Honors College, the Mechanical Arm 3D Simulator for Education. Our team consists of students from three different majors. I'm the software architect and the team leader in this project. Shristi Saraf is the software developer who is in charge of designing the API in the coding environment and the TCP/IP connection between the simulator and the coding environment. Wei-Chen Kao is the algorithm developer who is in charge of developing the forward kinematic and the inverse kinematic algorithm. Pei-Cheng Lian designed the 3D model of the mechanical arm and built the environment of this 3D simulator. Po-Shin Chen is in charge of the documentation, included the API and also the coding sample for our application. Since the development of 5G and API and AI, the mechanical arm and the robotic market have been growing exponentially and are expected to play an important role in every household within the next 30 years. The development of the mechanical arm requires cross-disciplinary students that could master both the software and the hardware knowledge related to the mechanical arm. A new term, robotic, is then created. It refers to the interdisciplinary field that integrates computer science and mechanical engineering. Students in the future will need to have knowledge of software engineering, mechanical engineering, electrical engineering, and even bioengineering to contribute to the robotic industry. But here's a problem. Even though the demand for talented people in the robotic industry is increasing, the job market has trouble supplying the demand. The main reason is the high cost of a mechanical arm. It creates a high stake for students to access this kind of equipment and knowledge, and therefore students couldn't develop sufficient robotic knowledge suitable for the job market. Most of the students could only acquire the conceptual understanding of the mechanical arm in school, but they didn't get the chance to access the industrial level mechanical arm due to the high cost. Lack of training and experience related to mechanical arm in real life leads to more critical mistakes and hazard after students entering the workforce. A safe and closed environment for students to learn robotic knowledge that is cheap and easy accessible is desired. For this project, we propose a 3D simulator that could simulate a mechanical arm and provide a general user-oriented GUI for students to use to understand the robot architecture. We will also provide a coding environment that is separated from the simulator that allows the students to control the simulated mechanical arm and learn robotic programming using high-level languages. This solution is cheap compared to the industrial mechanical arm, and it is easy for students to access. As long as you have a computer, you can learn robotic knowledge with a simulator on your computer anytime, anywhere. Students are also allowed to make any kind of mistakes in the simulator. If there is any problem, you just need to turn it off and turn it on again. Our project deliverable would be an application for the educational 3D simulator and a coding environment for students to control the simulated mechanical arm, to control the simulated mechanical arm. All of our code will be open source, include the simulator and the coding environment. We provide a high-level API and coding sample that is designed for beginners and general users to learn to control the simulated arm. We will also provide a communication protocol that is designed for the contributor to extend the functionality using low-level languages. Let's talk about our simulator first. Our simulator will provide the simulated mechanical arm along with 3 sliders that the user could use them to control each motor's rotation angle in the mechanical arm. The user interface will also show the current rotation angle of the mechanical arm and the Cartesian coordinate position of the suction cup. We will also provide an object that the user could use to test the ability to grab the object by the suction cup of the mechanical arm. Let's dive into some technical side of the simulator. It is made with Unity 3D and was built into a Mac OS application and was tested successfully of all the functionality on Mac OS. We broke the mechanical arm into 4 major 3D components and combined them with 3 motors and later attached each object with a C# script. The simulator will serve as a server that listens to the machine code sending from the coding environment and based on the machine code to rotate the arm or grab the object. A coding environment is a place for a user to write down code to control the simulated arm in a simulator. We choose Visual Studio Code with a .NET framework as our coding environment. We supply high-level languages in the application interface using C#. There is 2 major functionality that will be provided for the user to control the mechanical arm: the forward kinematic function and the inverse kinematic function. The forward kinematic function allows the user to specify the rotation angle of each motor, while the inverse kinematic function allows the user to specify the position the suction cup to move to on the 3-axis Cartesian coordinate. And then the algorithm will just figure out how to rotate each motors to get to that place by itself. We will also provide the grabbing object function that allows the user to grab the object or release the object like a normal mechanical arm. Let's dive into some technical side of the coding environment. We will use the TCP/IP protocol to connect the coding environment to the simulator. The coding environment will serve as a client and translate the high-level API into machine code and send it to the server that is hosted by the simulator. The simulator will then, based on the machine code it received, to move the simulated mechanical arm. The communication protocol of the machine code is open source and will be provided in the documentation for contributors or developers to extend the function or improve the function. Now let's check out our project demo. To download the simulator in the coding environment, we'll use the link that is given in the reference page and git clone the link. We will be focusing on 2 files here: the Mac app for the simulator and the software control to simulator platform file for the coding environment. Let's open the MeArm app first. As it can be seen, that includes the tutorial and also the credits. If we click in the Meet My Arm button and we could enter the simulator, it can be seen that you could move the slider to control each motor of the mechanical arm. The first slider is controlling the base motor for its rotation, and the second slider is to control the second motor for its rotation. And the third one is to control the upper motor. Now let's see how we can use the coding environment to control the simulated arm. We'll open the coding environment with Visual Studio Code. In the simple code, we first set up the velocity and the acceleration we wish each motor to move. For the first part of the movement, we use the inverse kinematic to specify the coordinate we wish the suction cup to move to, which would be the coordinate of the object we wish to grab. After getting the object, we use the forward kinematic to move each motor to the designated angle and release the object. Let's try to run the program using .NET Run. which is from the .NET framework. It can be seen after the simulator received the machine code sending from the coding environment. It will ask the mechanical arm to move the suction cup to the designated coordinate using inverse kinematic function. Grab the object and rotate each motor to the specified angle that we request using the forward kinematic function. At last, you will release the object. Pretty cool, isn't it? The sample code will be provided in our documentation so the users could base on it to learn how to control the simulated arm with our program. This is the end of our demonstration. For our future work, we are aiming to support our application to more platforms like Windows, Android, and iOS so that more people could be benefited from our project. For the big picture, we want to develop an industrial level simulator that can not only be used for educational purpose, but also by companies to develop and test their mechanical arm. This will be the end of our presentation. Thank you.